The word inequality is a statement that two quantities are not equal. It does not mean that they're not exactly equal, but it just means that there's a different way of setting up the relationship between two quantities. So if something is not equal, you can also be greater than, you could be less than, greater than or equal to, or less than it or equal to. So at times you will see, instead of an equation or an equality, you will see an inequality, which uses these symbols. The solution of an inequality is a value of the variable that makes the inequality true. For example, if I said to you, I am thinking of a number that is greater than 4, you would say the number is greater than 4, so anything bigger than 4, 4.00000001 is greater, so that is a solution of the inequality. 5, 6, anything that's really bigger than 4. The issue with this is that because there's an infinite number of quantities between 4 and 5, let's say, there's an infinite number of possibilities that the solution could be. And so the only way to properly express the answer is by using either set builder notation, which is just another way of describing a set of numbers, or a graph, and we're going to go through both of those in a minute. Let's start with the set builder notation. And you notice that we're using braces again, so sort of like the absolute value equations when the answer was 2 and -3, we learned that you can write it like 2 and -3, like that, or you could say x equals 2 and x equals -3. Well, with inequalities, it's the same type of concept where you use braces, but this is pretty much what set builder notation is. X is just the placeholder. It could be any letter. It could be Q, N, R, anything. And this line means such that. So the set builder notation, the way that you answer is, so for example, if the answer was that x is any number bigger than 0, the way you would write it now in Algebra 1 would be that you would say open brace, which means the set of all x values such that x is greater than 0, close set builder notation. So this is just a format. The form of writing it is called set builder notation. This is the basic way of writing it up here, x is greater than 0, and this is set builder notation. It will be important for you to understand the difference in meanings for words. For example, when you see things such as something was less than a quantity or fewer than, it represents the value of less than. Greater than, more than, at most, no more than, less than or equal to. All of these means that it's less than or equal to. If something is at most a value, that means that it's that value or anything less. At least means it's bigger, greater than or equal to. No less than, greater than, or equal to. So the difference between less than and greater than and less than or equal to and greater than or equal to is that with both of these here, it also includes the number you're talking about. In other words, if I said to you, I'm thinking of a number, and the number can either be 5 or anything bigger, you would say x is greater than or equal to 5. If, however, I said x has to be bigger than 5, it's a number bigger than 5, it's not including 5, so you would say just greater than. The way to graph, if you recall from last year, I'm just going to do a quick little review. If I said x was less than -2, what I am symbolically stating is that the value of x that makes this true is anything that's less than -2. You notice that it does not include -2 because it's not or equal to. And so if this was 0, and you're going to draw a graph like this, draw a number to the right so I know that you know the direction of the positives and negatives, a number to the left. Less than -2 means that it's not exactly -2, so it's an open circle, and we shade to the left. It's everything less than it. So less than and greater than are open circles. The or equals are closed circles. The standard form of writing an inequality is to have the letter, the symbol, and then the number. If you have it in this manner, the direction of the inequality symbol, such as this one here, shows you the direction of the shading. It is an arrow that shows you what direction you're shading in. So if you get an answer, if you look at this here, if x is if x is less than -2, you know that it's the same thing as saying that -2 is greater than x. These two mean the same thing, they're just written differently. This is what we call standard form, where the x or the variable is first. This is not standard form, but you can easily flip it by physically, if you see here, it's pointing to the x. When you flip x to the other side, you remain pointing to the x. And when it's in standard form, it shows you the direction of the shading. So that might be something that helps you out in the future as you're solving. So let's look at this. If I'm asked to graph these inequalities, let's start with letter B, just because it's a little bit less complex. We just talked about the idea that inequalities you should always write with the letter first. If this says that 7 is less than y, notice that the inequality symbol is pointing to the 7. You would write it here and make sure it remains pointing, and then put the letter. If 7 is less than y, I know y must be bigger than 7, or greater than 7. This is not a closed circle, it's an open circle because it doesn't have the or equal to. Think of the or equal to as it includes it. This is not or equal to, so it's open. And if you notice the direction after I rewrote it with the y on the left, again, make sure that you flip the symbols if you flip the variable. If you have a variable on the right, pay attention to where the symbol is closely pointing to. Here it's pointing to 7, so you remain pointing to 7. And y is greater than 7, and so that means that if I was to graph this, what you would do is you would get an open circle and shaded to the right, because everything bigger than 7 is correct. Going to letter A, you will notice that this is an expression, an inequality expression, where we can simplify those exponential terms. 3 squared is actually equal to 9, minus 2 squared is 4. So x is greater than or equal to 9 minus 4, which is 5. This one has or equal to. Extra ink underneath means there's extra ink in the circle. You go to 5. It's or equal to, so it means it includes 5, so it's 5, and I have a closed circle, and it's anything greater than or equal to, so I shade to the right. Again, if you have it in standard form with the variable on the left, the symbol tells you the direction of the shading. If x has to be anything bigger or exactly equal to 5, it means it is exactly 5, that's why it's the closed circle, or anything bigger. As opposed to this one, which is the same as y is greater than 7, there's no extra ink under here, so you don't use the ink in here, because here it's saying it's y is greater than 7, which means that it's bigger than 7. It doesn't include it. Okay, for the examples, all we're doing is graphing here, so this is pretty straightforward. Z is greater than -1/2. Your job is to go to the -1/2. Well, if this is 0 and this is -1, -1/2 is right in between. -1/2 is right here. It's greater than, it's not equal to, so it's an open circle. And greater shades to the right if it's in standard form where the z is on the left. If you know that z has to be bigger than 1/2, then you're going to go to the right, because everything bigger than -1/2, not positive 1/2, bigger than -1/2 is correct. All right, this one, s is less than 0. If s is less than 0, then you know that it does not include 0, which means it's an open circle on 0. Less than, which is what that symbol represents, is everything to the left. Everything less than it is to the left of it. Remember also that if the variable is in front, as it is here, the symbol actually helps you to show in which direction to shade. Okay, let's look through these. Hopefully, if you guys are watching this, you can pause it and you can try the next examples before we go over them. So go ahead and pause it. Try those 3 examples that you see here, A, B, and example 3, and then press play again and I will go over it. Okay, hopefully you have paused it and actually worked on it, and I'm going to go over it now. Example 2 wants you to write the inequality. So the first thing you do is you look at the significant number, which is 3. That's the one we have a closed circle on. So we know that the number we're referring to is 3. We're saying that the values of x, we know it includes 3, and everything to the right is greater. So x is greater than or equal to 3. For letter B, we know we're talking about 7, so we know that it's x in relation to 7. It's an open circle, so you're not going to have that solid line down here, so that's not going to be there. And it's everything to the left of 7, which means it's less than left. So that means that every value that has been shaded in here is actually less than 7. In this case, every value that has been shaded is everything greater than or exactly equal to 3. Ray's dad told him not to turn the air conditioning on unless the temperature is at least 85. Define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioning. Graph the solutions. So we know that he's supposed to maintain it at least 85. So hopefully you recall, at least means that it has to be greater than or equal to 85. And the variable that we're defining is temperature. So let's say T for temperature. And you can say T is for temperature, so that you can see what the letter signifies. Then they want you to graph the solution, so it's a number line. You don't have to make 85 tally marks. Just write the number 0, so I know that you know it's here. And you could put like -5 so that we know that you know that to the left is negative. And then you can go here and say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. I am going to be okay with you not drawing that many tally marks. If you wanted to just put in 85 somewhere to the right of 0, that's fine. So let's say that's 85. It's or equal to, and the temperature that you are allowed to adjust for the air conditioner for is if the temperature is greater than or equal to 85. So that means it's going to be greater than or equal to 85. You could have made a very simple number line and said, here's 0, here's 85. Here's -85, and anything that's exactly 85, so it's closed circle, or bigger. Just by doing that, that is absolutely fine. So either one of those would have been correct. All right, hopefully you understand this simple graphing, and you are going to go ahead and do your math space right now, which should be up, and complete the F2.1 math space, and we will discuss this tomorrow.